Hi all. In the previous video, we have seen copying the memory A to the memory B. Memory A has a depth of 512 and memory B has a depth of 1024. Here, the question or the problem statement where copy this data like 5122 to 1024. Just it has a bit 32-bit wide and memory B has a 16-bit wide. So we need to copy it to 0, 1, 2, 3, 4, 5 like that till it goes to 1023. And here for 0, 1, 2 in the same way it will go to 511, 511. So if I see that like in the previous video we have seen like how we can uh, copy the data. So we have not seen like much deeper values like for I equals to 1 and I equals to 2 and all. So see here like for understand the for loop here. For I equals to 0, let's say mm, int I will be 0 and one memory A, one random data will be generated. Let's say here I will be adding this memory A and all. Let's say this memory A, understand for I equals to 0 and mem A of 0 will be one random data will be generated for this one, and that random data 15 down to 0 will be copied to this memory B for I equals to 0. Okay, let's say here we have the memory B and mem B of 0 we have done, and for same way like 31 down to 16 mem b plus 1 mem b I plus 1 for I is 0, so 0 plus 1 will be 1. So this one we have copied. Now let's see what will happen for I equals to 1. So for I equals to 1 and memory 1 will be memory A of 1, one random data will be generated. Okay, and for memory A of 1, 15 down to 0 will be copied to this memory B of 1. Okay, so if you see here itself, we can say that again that previous the value will be gone. So we should not be, let's say, we now one thing is done. And for I equals to 1, 1 plus 1 will be 2. So the next upper bit data, meaning 31 down to 16, let's say memory B. So here 1 plus 1, I will be 1, 1 plus 1 will be 2. So if you see that this data will be, we are losing this data. So to avoid this condition, what we can do is, let's say uh, in this logic for memory B, like we should not be able to see. So for that, what I will be doing is memory B of 2 into I will be adding. So in the next, this is for lower bit data, and this memory B 2 into I plus 1, and this is for upper bit data. So let's see that how the understand like one more time. If I add this 2 here, 2 into I and 2 into I plus 1. So now for this anyway this 0 will be fine, and for I equals to 1, so memory A of 1 is fine. So here in the memory B location, so memory B 2 into I, let's see how it goes is memory B 2 into I will be 1, so memory 2. So here if I see mem b of 2. Okay, so now one more way in the sense the next upper bit data, this is for lower bit data and this is for upper. So 2 into I plus 1. So see mem b 2 into 1, like 2 into 1 is 2 plus 1. So if I add memory b of 2 into 1 first, this will multiply and then plus 1. So it's like Badmas rule I can say. So memory B will be 2 into 1 plus 1 like 3. So now in the same way, if I go with the I equals to 2, and what will happen is memory B 2 into 2 will be like 4, like memory B of 4. So 2 into 2 plus 1 memory B 2 into 2 plus 1. 4 plus 1 will be mem B 5. So this is the thing, like here we can retain our data as well. So if I go to the code again, like let's say I have updated the code with let's say some prints and all. Let's go back to this one. I'll add the previous code. Let's see that. And now save it and run it. Hmm. See, memory A data will be generated at 0th location, fine. And this 3536 is 0 at memory B at 0. And another the upper bit data 05E2 will be at 1. Okay. So here for I equals to 1, see what will happening is random data will be generated for memory A, but for memory B, lower bit data is this one A13C, A13C at 1. See, here already we have the data at first memory location, meaning one one location. So again we are overriding that data. So this is not the expected way. It's like whatever expectation is like 0, 1, 2, 3, 4, 5. Like that we need to copy. Now my data should become at this one. So, but here I can see that this is again going to as a one at one. So my data is going here. So this is not the right way. So for that, we have updated the logic here. Like we have seen that two will be better way. So if I go to this one now, update this memory. So 2 into I and add 2 into I. So here add it 2 into I. After updating this one, like we have updated at this 2 into I, and the value is be like memory of 2 into I, and let's add this 2 into I. And for memory B, 2 into I plus 1, memory A of this fine, and this memory upper bit data will be 2 into I plus 1. Okay, so let's save this and run it. Let's go to the top. Okay, so here if I see that memory zeroth location is fine, 3536 at 0, 05E2, the upper bit data will be at 1. Now the another data will be generated at memory A, like 57DE and A13C. So here if you see 0, 1 at the second location, whatever we are expecting like 0, 1, 2, 3, 4. So now we are able to see this A13C will be at the second, meaning at the third one, and this 57DE at the fourth one, 0, 1, 2, 3, 4, 5. Like if you see here, we are able to see the proper data will be generated at memory B. Memory is being copied properly. So in the same way, we should be able to see till 1023. So 512 is fine. We have crossed that one. So here 1021, 1022, and 1023. So here we are able to see whatever the data is generated at the memory A and it is being copied to memory B. So this is the final answer I can say.